This section is 11.7, Standard Deviation. The first word you're going to learn, there's a lot of words in this. So if you want to print this ahead of time to cut down on your writing, feel free. I've posted it in the assignment page. So a measure of variation describes how data in a set are spread out. Some examples of a measure of variation are range and interquartile range. Another one is standard deviation, and that's what we're going to talk about in this section. Standard deviation is the measure of how far numbers in a data set are from the mean. And it's denoted by the Greek letter sigma, the small sigma, not the capital sigma. Okay? So that might be a hard symbol for you to draw, but I'm sure you can do your best. Variance is another measure of variation, and that's denoted by sigma squared. So variance and standard deviation are very closely related. So let's find the variance and the standard deviation. Okay, it's kind of a bit of a process. So I put steps here as opposed to a formula because the formula probably wouldn't make any sense to you. So the first thing we do in finding variance and standard deviation is we find the mean. And if you remember from last time, the symbol for mean is X with a little line on the top of it. So we find mean of however many values are in the data set. Then we find the difference between each value and, between each value X and the mean. Then you square each difference. Next, you take the average of these squares, these squared values that you get, and that is called the variance, sigma squared. Then you take the square root of variance, and you get standard deviation, which is sigma. So we're going to do one together. I'm going to show you how it works. So here we have a set of data, 6.9, 8.7, 7.6, 4.8, 9.0. The first thing we're going to do, and we can use our steps from above, is find the mean, which is X with the line on top. And the mean, remember, that's if you add 6.9, 8.7, 7.6, 4.8, 9.0 divided by 5. We get 7.4. The next thing we're going to do is set up a table to organize, because to find the standard deviation and variance, I need to compare the mean to each X value. And so I can't do that all in one step. So we're going to have a little table here to help us organize. So in the X column here, we're just going to have the X values, the data set values. There they are. And what is the mean? Does the mean change? No, of course not. It's just 7.4. Oops. No, I don't want to create an event in my count. Oh my goodness. There we go. Then we subtract X minus the mean. And we're going to put that number right here. And then we do it again. 8.7 minus 7.4, 1.3. 7.6 minus 7.4, 0.2. 4.8 minus 7.4, negative 2.6. And 9.0 minus 7.4. Jumping the gun here. There we go. Oh, just like just ignore this guy for now, is 1.6. Okay. So then we take each of, I'll change the color on this. We'll take each of these values and we're going to square each of them. And then we're going to put the answers over here. Okay. So negative 0.5 squared is 0.25. 1.3 squared is 1.69. 0.2 squared is 0.04. And 2.6 squared is 6.76. And 1.6 squared is, oh, not this again, 2.56. So that takes care of step 2, find the difference, and step 3, square each of the differences. Now we find the average of these squares. That's step 4. So when they say squares, they mean, these squared numbers here. So we find the average of these 5 numbers by adding them up, and we get 1130. And we divide that by literally how many are there, so 5. And we get 2.26. So the average of the squares, that's sigma squared, and that's called the variance. If we square root the sigma squared, or we square root the 2.26, we get about 1.5. And that is the measure of the standard deviation. And the measure of the standard deviation tells you basically how spread out the data is, or the data are. So if it's a small standard deviation, then the numbers don't vary that much. But if the standard deviation is large, then there could be great gaps in the data values. So that's how you find it by hand. Okay. We're going to have another example now. Example 2. This table displays the number of U.S. hurricane strikes by decade from the years 1851 to 2000. What are the mean and standard deviation for this data set? Okay, so here's our data set. We have decades 1 through 15, because from 1851 to 2000, that would be 150 years. And in this row here are the number of hurricane strikes. I don't know exactly what they mean by hurricane strikes, but whatever, it doesn't matter. So these are the number of hurricane strikes in each of these decades. So in 1851 to 1860, it looks like there were 19 hurricanes. Okay, and so on. So the first thing we're going to do here is we're going to enter our data just like we did in the last section. And you always enter data in stat edit. And we're going to put our data in L1. Now the only numbers you have to really enter are the strikes. Because we're not really dealing with 2 variables right now. We're really just dealing with 1. So you don't need to enter the decade. That's not necessary. You just need to enter the strikes, and you can do that in L1. So take a minute in your calculator and enter in these numbers. If you need to pause the video, pause the video. And then when we're done, we're actually going to use the same command that we used in the last section. So stat, calc, and the 1var stats. So if you remember the 1var stats, there was a long list of analysis when you had the calculator do that. So let's look here. This is what we would get. So we enter the data. We press stat, calc, 1var stats. And let's look at what we got here. So you remember this from yesterday, the day before, I'm sure. That's the mean. Let's write that in there so we don't forget. Okay. We're not going to worry about this right now, and we're not going to worry about this right now, and we're not going to worry about this right now either. But I don't know if you notice this, because it's a little weird when it's printed. But look at this. Look at this right here. That's a little baby sigma. They did the best they could there. But there's the baby sigma. So this is standard deviation. Okay. And then if you scroll through, you can see all the other data that we found, like with the box and whisker plots and stuff. So we have the minimum and the median and the maximum and the quartile 1 and quartile 2 and all that. Okay. So what does any of this really mean? What is standard deviation? So what we're going to do is we're going to take these data numbers and we're actually going to make a little line plot. This is one of these plots where you put little X's for each data value. So we're going to make our scale start at 10. Nah, I can't do it. I tried to erase, but because I wrote it by hand, it's not going to work. So 10, and we're going to go up by 2s, and we're going to end at 26. Oh, I was able to do it that time. So label all these dashes, go up by 2, so the next one is 12, and then 14. Oops, it's not working. Just can only get my 1s. No. I'll just make that go away. That's fine. I can come back and do that later. Ah! Bad idea. Oh my gosh! It's never ending. Okay. So this will be 12. I think I lost a line here. This is 14. 16. Let's see, that's 24. That's 22. Yeah, so I need 18 and 20. Okay? I mean, you could split up, your scale however you want. So if we fill out this line plot, you'll see that the lowest value on here is 12 right here, which you can also see here, right? Minimum is 12. So we're just going to put a little X there. Okay, are there any 13s? Yes, right here. So we're going to put one right there, right in between 12 and 14. So we're done with him, and we're done with him. I see 2 14s. Oop, not him. Wrong one. And I see 2 15s. I don't see any 16s. I have 1 17 and 1 18. 2 19s. Is that correct? Yep. 1 20. 2 21s. A 22 and a 24. And just in case, let's count these up and make sure that I got them all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There we go. Okay, so I make sure I got them all. Okay. So where's the mean? So if you look back right here, you'll see the mean is 17.6. So that's, a little bit before 18, maybe here. So we're going to put a little dot there, and we're going to label this 17.6. That's the mean. Okay. Now, how big is the standard deviation? The standard deviation is about 3.5. So what we're going to do is we're going to just sort of draw a line on here from the mean 3.5 away. So if we add 3.5 to this, I'm going to get 21.1. So maybe like here. And I'm going to put a dot there. I'm going to come down here and I'm going to say this is 1 standard deviation above the mean. Okay. I could also go the other way. So if I subtract 17.6 minus 3.5, I'm going to get 14.1. So that's going to be right about here. And that is 1 standard deviation below the mean. Okay, let's talk 2 standard deviations. If 1 standard deviation is 3.5, then 2 standard deviations would be 7, right? So let's go back to the mean, because it's all based on the mean, and let's go 7 above to 24.6, which would be about here. No, that would be 25.6. That's 25, so here, there we go. So I'm going to drag this line out here. Actually, I'll even put another little line on there. There we go. And this is 2 standard deviations above the mean. And likewise, I could do that below as well. So 7 below 17.6 is 10.6. So about here. So if you look at this data all organized here, it was neater the first time I did it, but you can see that all of these X's here, they're all within 2 standard deviations of the mean. Right? Are there any X's, way out here? No. Well, that probably would have changed the standard deviation too, but that's okay. So that's something that, a statistician might be interested in, that all of the data fall within 2 standard deviations. That's how it would be said. So all values fall within, I'll get rid of those, 2 standard deviations of the mean. And I know you might not care about this right now, but certainly if you decide someday to take AP statistics, this will be very important. Most people have to take some sort of statistics course in college, and you'll learn it again in great detail, but it is nice to sort of, have seen it before. That way it's less scary when you learn it in the, in the big leagues when you go to college. So I hope you learned something from the video. You can certainly use your calculator to find standard deviation. It's more about interpreting it than actually brute force finding it by hand. This whole table thing, I don't think people really focus on that anymore because, your calculator does it for you. So you may use your calculator to do the homework problems. And if you have questions, you can feel